Hi, this is for example 2 of chapter 13 on cylinder. Right, yeah, you should be referring to your notes. Okay, so I'll not go through the detail of the question. So now for part 1, okay, show that the area of the cross-sectional area of the pipe is 1.84 pi. So you see for this question, they want it to be in terms of pi. Okay, so remember that when you're calculating. So what is the cross-sectional area? Now I have the top view of this. I draw it here. So the top view is this. So as you look at it, well, it's similar to the toilet paper that I show, right? So it's basically the top view, okay, the toilet paper there. So the shaded region is what we want. So this is, I believe, what we have practiced before in primary school. So area of the big circle minus the area of the small circle. So pi r square, so 2.5 square. Area of the big circle minus away area of the small circle. So I'd like to write this one all in one line so that it is neater. Yeah, I do not need to evaluate one by one. So with this, what is it equals to? Now, because we have the knowledge of algebra now, I need it in terms of pi. Basically, you treat pi like x. Okay, treat it like x. So in my calculator, what I will press is this. What I'll press in my calculator is this. Right, the coefficient. So I literally treat pi like x. I'll get is 1.84. See? Okay. So I get 1.84, and just like the x, I put it back to pi. cm squared shown. Okay. So for show question, you need to end off with the shown. Okay, to say that okay, this is my final step. I shown the answer. Okay, this is part 1. Now part 2. So find the internal curved surface area of the pipe. So internal basically it means on the inside here. Okay, so we do not need to care about the outside circle. So internal curved surface area of the pipe. So what our have will be curved surface area is 2 pi r h. Okay, the formula is 2 pi r h. So 2 pi, my radius is 2.1. My height from the diagram is 12. Alright. So with this, same thing as the previous example 1. Alright, I will encourage everyone to write this one first, 50.4 pi. Then you multiply in the pi, which will give 158 cm squared 3sf. Alright. Okay, can? Okay, now next, part 3, we need to find the total surface area of the pipe. So total surface area, okay, I'm going to bring back my beloved toilet roll again. So total surface area of, let's say this toilet roll. Okay, just some explanation first. Total surface of this toilet roll is the paper on the outside, the top, okay, that means the like the donut shape, okay, and includes the inside also. Okay, in short, total surface area are all the surfaces that we can touch. Okay, imagine it, your hand that you can touch all these surface area. All these are the total surface area that we need to calculate. Right, so with this in mind, okay, I have literally almost all already except for the curved surface area on the outside. So I'm going to calculate that. Okay, so I'm going to calculate that. 2 pi r h. So just take note, this one I'm just writing down as a generic formula. So it's 2 pi r h. Alright, so now my radius is 2.5 because I'm calculating the one that is on the outside. So 2 times 2.5 times 12, I'll get 60 pi. Alright, so this one I do not need to evaluate because it's not the final answer. So hence find the total surface area of the pipe. Total surface area. Right, first, the cross-sectional area, top and bottom. So it is basically the answer in part 1. So 2 times 1.84 pi, right? Plus the curved surface area in the middle. So you see, in this case, I can use my 50.4 pi. Over here, take note, do not use 158. You cannot use 158. Right, so over here, cannot use 158. Right, because it will result in your error in accuracy. So the whole thing, you press calculator, you will end up with 358 cm square 3sf. Alright, so there you have it.